Welcome everybody. I'm Dan Conger, Baseline's training manager. We've got a Tech Talk Tuesday, and with me, Jeff Hume is here. Jeff, thanks for joining us.
Thank you for having me.
And Jeff, what's your region that you cover in for Baseline and Weather Track sales?
So I am the Northeast Regional Manager. I cover from basically Michigan East down to the Washington, D.C. area.
Awesome.
Yep.
So one of the reasons I have you on is kind of like why I'm talking about my shirt. So I live in San Diego, California. I have never winterized a system. And here I am talking about winterizing a system. So I just kind of embraced the full tropical look and I'm running with that today. So you definitely get snow, you definitely get freezing in your climate. In my 35 years of industry experience, I've had one freeze incident, and that was just isolated in a backflow prevention device that was above ground. It was one night and it was one ball valve. So
Yeah. Well,
that's my
right. And it's funny, but this year it's been an unusual year. Obviously, the drought has affected everyone, but
right.
it's been, unnorm not our
Not
normal
normal.
summer where we where we've had a lot of heat as well as drought. So
Awesome.
this fall there's been a lot of overseeding, and so I think people are holding off on winterizations because they're still trying to establish the new seed. But
Sure.
uh, it seems like right now though that if they haven't started, they're starting this week. So
So one of the things I kind of wanted to start off with was winterizing a system versus shutting down a system. And there's probably some differences that are worth discussing. I'm probably in the market, or parts of my in the Southwest would probably more likely to shut down systems for the winter or for a period of time. Whereas you all are going to do really true of a more winterizing and just protect and isolate your system in addition to just shutting it off.
right.
Um, like, so for me, it might be just as simple as shutting off the controller, maybe shutting off the water source, and that might be the extent of it. Maybe, essentially putting your system to bed for the year. But a good thing to remember for either way, for winterizing or just doing a simple shutdown, is any problems that you shut down your system with, they're going to be waiting for you in the spring, right? Not counting any problems that may have happened over your winter freeze.
True. Yeah.
So today, especially given my background on this one, our intent is not to tell you how to winterize your system. So for sure, I'm not the person, even Jeff, right, that has an experience in the colder climates. We're not going to tell you how to blow it out, how to turn on these valves and do all that stuff. You've got your system that you do, and it's probably varies slightly from region to region and on scale of system. So that's not what we're here to talk about. We wanted to talk about how you're going to protect your baseline equipment and then some things that might make this system, your process, a little simpler on you using some of the baseline features and some of the hardware that's in there. That's kind of our goal. So I think the question I want to ask you, Jeff, is when is a good time to winterize the system? How do I know when to winterize the system?
Well, I mean, I think you want to. It really depends on the region, but when your plants start to go dormant, and when
Yeah,
soil temperatures start to drop, and I mean, I think it's from experience, people kind of realize when that's going to happen, but they also have to look at what is their customer base and how long is it going to take for them to do it. So sometimes they may have to start a little bit sooner than they would like, but for the most part, like I said, if you're not overseeding, in the New York North market, you're probably looking at, sometime in October to start your
okay.
winterization.
And the things I've kind of found is working with people across the U.S. is in the East, they're going to start as early as October. And as you move to the Midwest or to the mountain states west, it's going to be a little later and later and later, or northern climates. Um,
Right.
yeah, and I've met with some people. I was in Minnesota in October one time, and we briefly met with somebody that was working 12, 14-hour days blowing out systems, and they just had a big toe behind compressor, and they're trying to make hay while the sun shines and get all their stuff done. So,
Mhm.
so I got to imagine, so we've got plants going dormant prior to a freeze. That would probably be an important one for, to protect stuff. Um, One that I was kind of thinking about was there might be seasonal water supplies that shut off. And you and I were talking about that. So I
Yeah.
know by the factory in Boise, they've got a canal system, and you can pull from those canals. Some people can pull from those canals or those surface water supplies, and then at a certain period of time, they're going to shut down that water supply and you can't use it. That would be a good point to shut, in which to decide to winterize your system. The other one that I kind of thought was good was you could use on our soil moisture sensors, right? We've got the moisture sensor on the blade, but built in on the bicoder side, there's a temperature sensor in there. So we have soil temperature. So you could use that as a good indicator. So after you get a few records, a few years, you could see as the soil temp starts dropping, it's like it's getting time. Or if the climate is, if we're noticing that it's doesn't cool off as soon, right? If you I'm trying to figure out how to address this without saying it. If you're seeing that the climate isn't as cold as it once was, how's that? That you could just track it off a soil temperature. So when the soil temp hits 40 degrees, it's way past time then. Now, the thing that always kind of threw me is that I kind of realized that air temperature and soil temperature, there's always a lag between those two. So do you know what your soil temps are running right now?
They're in the upper 50s at the moment. So,
Okay. And then
and our
what's
yeah,
your nighttime lows right now?
nighttime tonight we're going to be down into the upper 30s, is what they're
Okay.
saying. So, there's potential of frost in some areas. So,
So it's going
um,
to take a while for that soil to really cool down to some of your low temps.
yeah,
And it's probably going to be late winter. And so horticulturally speaking as well, on the other end, it's going to be a lag. Just because we have warm air temperatures doesn't mean that the soil's warm, and it doesn't mean the plants are waking up and the root growth is happening. So good point. But the temperature sensor on there is a good thing.
yeah,
Another one that I kind of liked was, so what happens if I want you to imagine a scenario where I'm still irrigating in the fall, however often I need to irrigate, and then I get a cold snap and it freezes and I haven't blown out yet. Maybe it's not going to damage my system, but a freeze and water running across the sidewalk does, I don't know about you all, but that should strike the fear into most any contractor or anybody managing a site. We're talking about runoff and ice, right? And ice on a sidewalk that you are responsible for. So we could stop that. You could help prevent that by using an air temperature sensor. You could try and use a soil temperature sensor, but the soil is always going to be so much slower than air temperature. Use an air temp sensor and then a stop condition, either a global or a program-based stop condition, and say if the air temperature ever drops below 40 degrees, stop my irrigation, and that would prevent those ice up events. Yeah, nice. Okay, cool. So that's kind of the general guidelines on when to winterize. Ultimately, records and keeping that's going to be a smart move for you. Tom dropped in the chat that turfgrass programs. So this is turfgrass when it's going to go dormant or when it's going to come out of dormancy is 65 degrees for that activity threshold. I think and that's probably also going to depend on warm season versus cool season turf. And people that blow out are more likely going to be using cool season turf, perhaps. I don't know, because here in the Southwest, definitely more warm season grasses. So main steps we're going to talk about, just high points: turning the water off, draining water out of the devices, protecting the devices from freeze, and then turning the controller off. So let's pick apart that first one: turning the water off. Okay, well, Jeff, what do you think we're going to need to do for turning the water off?
well, I mean, you want to start at the water source. So I want to see, want to make sure that the main water supply is shut off from prior to the water meter or just after the water meter, depending on how the
Yeah,
setup is.
yeah,
Um, and then, backflow prevention, you got to make sure that that is drained as well. Um, I know that you and I had talked about some of the common practices with the backflow preventer, and after you shut off the water, it's a good idea to keep your ball valves and quarter turned or a half turned, so that the if there is any water trapped in those backflows, that there would be that it would have room for it to expand. So, um,
Which is funny you bring that up because that is my only one experience was I had a backflow prevention device above ground, dropped to 28 degrees for one night, and the ball valve was closed and there was water in the ball valve. No room for it to go. Crack the brass casing. That's all I got as far as, damage stories. I replaced the ball
right.
valve and I was good to go.
And that's a difficult repair to make. I mean, that's
Yeah,
not a fun repair because of the copper and the threaded ball valves. And yeah, it's anyone that's ever had to repair one,
yeah,
it's a challenge. So
yeah.
yeah.
So getting the water out, right? Where it's basic draining. Um, it's maybe you got a gravity drain system. Maybe you're gonna have to blow it out. So that's probably the next steps, right? So we've shut off our water supply, whatever that is. Winterized, shut down our pump, shut off our backflow, shut off our water meter. But then we're getting the water out of the system. So there still are some systems, and I think our discussion was that sounding like it's larger scale systems, maybe golf,
Yeah,
that actually have
right.
drain. They actually fall like a drainage system, and they'll have drain valves, which is brilliant. But it's a lot more work to install it, because you need to set everything at a gradient.
Yeah, and a lot of people will, even on smaller, commercial um, sites that may have quick coupler valves, may blow the water through the quick coupler valves first to get the main line clear of as much water as possible
Yeah.
before they go
It,
into the zones. So,
so
it's
Lincoln
a
was
similar
asking.
concept. Yeah. Yep.
A
Sorry.
Lincoln just put a question in the chat, was like, do you still have gravity drain valves if you're using a blowout? And the reality is I think when I came into irrigation way back when in the 80s, I learned about drain valves, and I always thought that was the way that people did it. But I think I suspect, and this would be a good cold climate installer chime in. Um, and my take on it is that gravity drain valves for gravity drain is fantastic, but it takes a lot more work to install it. And if you could just install the pipe the way it needs to go and have bellies in it and just have it follow your terrain, that's going to be easier, and then blow it out. And the idea, either way, that the goal is to get the majority of the water out, right? Not all of it, but the majority of the water. So let's kind of switch gears to blowing it out. So I've got an air compressor in my garage. Maybe that'll work. Probably,
Probably
probably
not.
not. Probably not. You see, the big thing is, right, it doesn't have the volume. The compressor in my garage, it'll get up to 120 psi, but it's the volume, right? Because we want to move a large volume of air at a slower speed and a lower pressure,
Low
right?
pressure.
Yeah,
Absolutely. Yeah.
right. So the thing to remember about water and air, and this is like kind of a basic hydraulic thing, is water is not compressible, air is. So that's one of the reasons we want to move it slowly is if you've ever had compressed air in a line and you bleed it out, well, like on initializing a new system, it's kind of scary because when the water's coming through and then it gets to that pocket of air and it expands because it was compressed. So definitely makes sense to be careful with that one. So again, our goal is not to tell you how to do this, but the idea is to blow out as much of your system as you can and then just run through your zones and to get the majority of the water through there. That's going to clear out your main lines and the bulk of your laterals. Then we kind of jumped ahead. So we're talking about the other devices in the system. So well, actually, we're going to come back to devices in a minute. So blowing out the system. So there's a couple of ways to do that, right? So we're going to have to we need to get water out somehow. So we're going to put air in and we need to get the water out, ultimately running until we see some air and some water spray coming out. So I got to turn on some zones, right? So let me jump over and show you a program that I have set up. So I'm going to show you something in Base Manager that I've got set up. And I do have the right screen share, yes? My
Yeah.
Base Manager screen. Thank you. Okay, so let's jump into my controller and take a look at what I've done is I've set a couple of different programs here that I'm going to use for blowout. So let's make sure we got my right controller. There's my 3200. Okay, and then under schedules, I've got two separate programs set up. I've got a west side blowout program and an east side blowout program. And let's open those up and I'll show you why I've got two different programs on here. So here in this program, this is enabled, yes, right up here. And I've got 5 minutes set for this, for each of these zones. I think that's kind of interesting is I don't, let's go to edit so you can see a little clearer. I'm going to edit. If you notice, I've got days enabled, but I don't have a start time. So this program will not run until I give it some reason to run. So it cannot run on its own. It will only run if I somehow tell it to run. Well, what's nice about this is I don't want this to run on its own. I want to be the only person that runs this. So what I can do is I can come over here and start it and run through that entire sequence of zones. But if we look at that again, we notice the zones in here. These are my odd numbered zones. Well, this other one is the even number zones. I'm not creating a program based off of drip emitters or shrubs or turf. I'm just creating them based on where they are on the site. I don't know about you, but I'd rather not run back and forth if I don't have to on my site. I mean, do you have I gotta fit. Do you have a pedometer, Jeff? Do you try and keep track of your steps?
I don't. I should, but I
You could
don't.
get extra steps if you run back and forth, or you could be
Yeah.
smart and just look at it and follow it in
And,
the sequence around the site.
and you're trying to chase the water out as well. So, creating that program is, from the closest point of connection on out to the furthest,
Right.
is generally what people do. And that's how you're kind of chase the water out of the system.
So with these programs, I did two things. Is I put those way down here at program 40 and 41. So I put a gap on there on purpose. I don't want to accidentally run these programs. Okay. And so I did that. And so that allows me to just come in and run them when I need to. And then I separated and I've named them. So I could run them. And let's start this one and let it run. So this will take off in just a second. We'll wait till it gets going. Uh, Did I click it? Oh, I did click it. Okay. Let's tell it. There we go. Okay, so I could also run this through the controller itself, right? So I could come over the controller and start the program and tell it to run as well. So we could do it either way, either through directly at the controller or through Base Manager. But Jeff,
I was going to say it'd be great to set that up for your technician that's going to be out there.
Oh yeah,
Set that up ahead of time in your office, much easier through Base Manager, and then just let them know which programs they need to go to, and they can go up and manually turn on that program
right.
when they're doing the winterization. So yeah,
So
and beautiful thing is you've got 99 programs to work with, so
there we go.
3,200. So these can be stored, for next year as well.
That was an excellent point. The 99 programs, because we've got lots of programs to work with. Let's take advantage of them and start using them to our benefit. So the other thing we talked about is how long. Oh, I actually got to run this on my phone. So I'm sharing my phone screen, and maybe 5 minutes is too long because maybe you're not going to run it that full length. Once you start to see air coming through there, you can move on to the next one. Well, we could also do this, and maybe this all makes more sense to do this through mobile access. So I could come over to mobile access and manually run a zone. So let's come into zone 1, and this is the default runtime is 10 minutes, and I could change that to 5 minutes, and not log out, which would make it more convenient while I'm doing a live webinar. Got to learn to just kind of roll with it, Dan. So we could start a program. I was saying 5 minutes, 5 minutes, and then start it. And then that's running. But as soon as I see air coming out, I could stop it, advance to the next one, and then start the next zone, right? And I could do that all through mobile access, or I could start the program. So I could do that either way, right? We could start a program if that works for you. I could start my blowout program, or I could run individual zones if needed, or if I needed to kind of do a clear up. I've had a couple zones that weren't quite done. I could go back in and just catch those onesie
Yeah.
twosies. So,
Right. And some people, I think they are in the practice of maybe doing it a couple times anyway, depending, especially on larger systems. They may run through a couple of minutes for the first time that they have the compressor on, then run through again, and just to
yeah.
make sure that everything does get.
I love Greg's comment. Blowing out irrigation pipes is just like barbecue, low and slow. So yeah, so while we're talking about that, let's talk about the devices. So we're going to talk about protecting your devices. And one of the things I wanted to talk about was your flow sensors, right? So here I've got a PFS, there's a plastic flow sensor, and this is really what our concern, my concern is the paddle inside of here, right? So if I have the potential of cranking that through and spinning this at a really high rate. Well, that's just there's no ball bearing. It's just a super simple plastic and metal bearing. You could prematurely wear that out and spin it off and do some serious damage to this device. So it's always better to not blow through this. Maybe you can risk it and blow through it slow. We're going to recommend don't. Okay. But what were we talking about, Jeff? A lot of people still do.
They do. Yeah.
Yeah. Okay.
Yeah. And I
So
usually that's at the point of connection. So if you could have the ability to blow out after that, and shut that down, and if you have a drain built in somewhere at the point of connection, which generally you do anyway, some
yeah,
sort of boiler drain or something that you would have access to filling a system, or having access to live water. So if you could drain through there and avoid running air through that, I think you
yeah.
are in a better spot. Now they also do make a plug for that we sell.
Right.
Yeah.
Right. So the insert comes out and then there's a solid cap that you could get and then just pull that insert out, put that in here, and now we got a solid cap and then you can blow through it at your heart's content. Right. So that could work too. So definitely. No, I was looking on LinkedIn and I saw someone that had a great picture of a bypass that they set up. I'm like, wow, that was pretty impressive. They had a bypass to not blow through the flow sensor. An ultrasonic, probably not an issue. Probably, it's much more. There's no moving parts in there, so that would be nice. Um, the other part I left over here was a pressure transducer. So I can talk while I'm walking, which is nice. And the So in the pressure transducer, that's also something, right? This is a rubber diaphragm in here, and you want to protect that as well. And you want to be careful on that one. So the manufacturer does recommend not allowing water in here. So definitely, any water in here and it freezes, you risk damaging it.
Yeah.
And I'm saying you're risking damaging it. Are you going to damage it? I don't know. But do you want to find out? Well, it kind of depends.
Yeah. I've recommended to people that you remove that and shake out any excess water. And if you want to leave it out over the winter, as long as you kind of protect it in some way with tape or
Yeah.
whatnot, and also cover up the tee that it was threaded into, then I think it would benefit as well. So
Sure.
same
Okay.
thing would be with the flow sensor. If you can remove that, shake it out, make sure the water is out.
Good.
I guess I'm a little overprotective of those
Yeah.
devices. I mean, they're expensive devices, so
Sure.
you want to keep them intact. Yeah.
Now it's your all's project. So whatever risk you want to take, that's on you. But we're recommending you be safer and take it
Right.
with a grain of salt if you like. So, and then we also mentioned ball valves on. So getting the water out of that backflow prevention device if it's above ground. If it's below ground, still getting the water out is a good idea, as much water as you can. And then having those ball valves cracked, so they're partway open, so we're not trapping water. Because again, the whole big thing on a ball valve is there's no room for expansion, and it doesn't matter. It could be a tablespoon of water, it could be a gallon of water. If it's got no place to move, as that freezes, it's gonna expand, and
Yeah.
it has some serious force.
And even on the isolation valves throughout the system, good idea.
Right,
Yeah.
right. Yeah, I can imagine plastic isolation valves just cracking all over the place with
Mhm.
hardly any freeze. Okay, the last one, this is timing out about right. The last couple things we wanted to talk about was the controller. So not allowing the controller to run. So two things to think about that one is powering it off versus turning it off. So powering it off, that's fine. You could just power it down, kill the circuit breaker, unplug it. You have no data over the winter. You have no data up until your spring startup. So what were we were kind of talking about knowing when to start your system back up again. Well, if my system is remotely off and you have soil moisture sensors, I can start getting soil temperature data. I kind of like that one.
Right,
And
similar to
then
what Tom had mentioned, at 65 degrees, is that when you need to start it?
right,
Yeah,
right, as it starts
it
warming up,
depends,
right.
depends on the season, the turf type and your climate. So yeah.
Right. So what I'd probably do is I might guess that in preparation of that, when the soil temperature hits this, I'm going to turn my irrigation system on and go, because it's probably going to take some time to go through and find those problems that you put it to bed with, those broken heads and clogged nozzles and whatever, leaking valves. The other one that I really like, so Tracy Shields is in the Mountain States, so Colorado region, and they're cold, but cold and dry. So they don't get a whole lot of snow or rain, but it's just darn cold. So they get lots of freezing. So they winterize their system, but the soil can be really dry. So their trees, even though they're dormant, the dry soil can suck moisture out of their tree roots. They actually need to roll water trucks a couple times a season to get to wet those trees. Well, that's a lot of labor to go fill up a water truck, drive it, pay somebody to do it, and to water those trees manually because the irrigation system's set off. This might be a cost-saving device. They can they can remotely check the moisture content in the soil because the controller's on but not running. It's powered up. They can see that the moisture content is dropped below whatever percent. Say, ooh, we need to roll a water truck, or no, we're fine. We're good for another. Let's check it in a couple of weeks and see if we need to do it. So I thought that was it was a concept that I had never heard of, and I really like it. Cool. Oh, we had one. What was the one you were talked about? Heat generated by the controller. What was
Oh,
that?
yes, yeah. So I mean, from an old school golf course superintendent, had always told me that, leave the power on to the controllers if they're outside, because that helped generate just enough heat that would keep the condensation from destroying the boards inside. So if you had turned off the control or shut down the power to those controllers, then there's a possibility that over the winter you could get some condensation inside and do damage to the
Okay.
circuit boards. So yeah, little thought, but also keep in mind that could be a nice environment for some rodents. So make sure you've rodent proofed
Sure.
your controllers as
Yeah.
well. So
I had one question that popped up in the QA. I want to do that, and then we'll call it and we'll wrap it up. Bob asked, any recommendation on compressed air through hydrometers? So a hydrometer, right, is a combination master valve and flow sensor, and it's a little bit different type of a flow sensor. It's not a paddle style like this one is. It's a disc style, most water meters. So it's got a disc, and every drop of water, every gallon of water that goes through that meter goes through that disc. So it does revolve differently. There is more likely to have water trapped in there. On the hydrometers that we have, there is a drain port down in the bottom. Can be kind of finicky, but that can allow you to drain water through there. Um, if you're going to run air through there, you need to be very, very cautious on that one. So probably not recommended,
yeah,
but
it's not recommended.
use the drain and give it as much room as possible. So drain before and drain after. And then probably the way to kind of avoid that is if you can drain those devices individually, that's always safer. And then if you have a quick coupler right after your master valve, then you could introduce your air and run it forward, maybe with an isolation valve so you don't blow backwards through your master valve, and you can push it out and blow out your system and allow that. So, well, Jeff, we burned through another half
Yeah,
hour.
awesome. Great. Thank you, Dan.
Okay,
Yeah.
absolutely. It's always great spending time with you all. Jeff, thank you for your time.
Thank
Have
you.
a great winter, everybody, and have a great Halloween, great rest of October. So take care,
Okay,
everybody. We'll see you soon.
thank you.